So, hello everyone. Now I guess we can speak in English. And thanks for coming to my presentation. It's for me very nice to see so many people here today. Today I will tell you about my project. It's called Smart AP, Smart Autopilot. This is a UAV flight control system. But first of all, I would like to say thanks to Elena Viktorovna for the great opportunity for me to speak today, and for Svetlana Viktorovna for being a very nice English teacher who gave me great knowledge. And I must say that the English language courses here at MIPT are really great, because they give you nice knowledge on how to do presentation, and this is very useful in your future research, developments, work, and just personal life. So let's get back to the presentation. This is the plan. First of all, I will introduce a little bit more myself. Then we will talk about the UAVs, the drones, the applications of them. After that, we will get into the technical insight to bring you the knowledge about what it is, how it works, since you are VSTEC students and very interested in science and all this related stuff. Then I will tell you about the promotion plan project, the current results, and in conclusion I will outline the results and give some more information. So my name is K.Shilov, and I'm a 6-year student here at DAFE MIPT. I'm majoring in flight physics and having a very strong background in web programming, and now my interests are electronics, programming, embedded systems, microcontrollers, focused in navigation, control, and unmanned systems. So I have started my project, which is called skydrones.com. Actually, this is the website, and it was started in October 2011. So this is about UAV flight control systems. I'm designing my own hardware and software, and the main product is Smart AP Autopilot. By the moment, I already have 3 generations of the system, and my target in the project is to achieve the system integration, the autonomy, and the ease of use of drones. So there is a big variety of applications of drones. You can see all of them listed on this slide, but mostly all of them are focused on aerial photography and videography, just to put the camera into the air somewhere. So the market survey shows that the drones market is expected to be really big in the next following years. And some years ago there was a problem that if you want to take an aerial footage of something, you need to rent a helicopter with a cameraman, and this requires very highly trained employees and quite sophisticated equipment. After that you get very limited white area, so it's complicated, it's expensive, and it's not appropriate. And several years ago, thanks to the latest developments of electronics, we are able to use drones, which are very easy to operate. The training is not required because they are quite simple. We have unlimited flight area. They are very affordable, easy to use, meaning that it's a very simple solution for aerial applications and tasks. So my business model looks like this. There are more than 1,000 companies which are developing UAVs today, but what they do, they just design and produce the airframes. So more than different types of frames, more than 300. And so what about electronics? And the UAV is electronic device, actually. So the electronics is quite sophisticated and complex. And there are less than 20 companies all over the world designing the flight control systems. It's quite few, isn't it? And even guess what? They don't meet the customer's requirements. So what I can offer the next generation flight control system. This is the solution for different types of UAVs, for different applications, and all of them meet customer requirements. So now let's get more into the technical details. So autonomous UAV actually consists of 3 parts. This is the vehicle itself, this is the flight control system, and the ground control station. So I have a question for you. What is the most important, do you think? Which part?
All of them.
Yeah, that's correct. But now we take a deep look into the second one, the flight control system. So it consists of actually 3 steps. The first one is to get the information from sensors, which you have on board. This is in general, inertial navigation system and global positioning system, GPS. Secondly, we do data processing in order to get better results in navigation and in measurements. And finally, we do the control to perform stabilization and navigation of the vehicle. Stabilization is the ability to stay in the air, and navigation is the ability to fly the vehicle autonomously wherever we want it to fly. So the system architecture is based on our microcontroller, STM32, and it has accelerometers, gyroscopes, magnetometers, pressure sensors. This is required to estimate the orientation of the vehicle in space and also to determine the location of the vehicle. So the software stack is divided into 4 layers. The lowest one are libraries from microcontroller, and the top layer is the flight control system algorithms. Also, we have some peripheral external ports to connect different devices. So I offer the solution, which is the flight control system. So this is the printed circuit board design. The size actually is quite small, just 60 by 40 millimeters. This is how it looks like. And also this is, you can take a look if you want. So this supports types of UAVs. This is quite simple solution for integration in any type of UAV. It's very easy to use. So it's based on my custom hardware and software. It's compatible with the ground control stations. It's quite stable and it's capable of precise flight. I have implemented the latest electronic components available at the moment, and all intellectual property belongs to my company. So now let's get more into math, into the software. So the most important part is to estimate how the vehicle is orientated in space in order to stabilize it. So it's based on digital motion processor, which outputs the data in quaternion representation. Does anyone know what quaternion is? No? Okay, so here is mostly first year students, right? Yes, so you'll learn more about this next year. So we get quaternion representation, and after that they are converted to Euler angles, which are roll, pitch, and yaw. I guess you're familiar with these words. So the inertial measurement unit, this one, gives us this solution. And after that, we know the orientation of the flight control system and therefore the orientation of the vehicle. After that is going control system, which is stabilization and navigation. It is based on PID-based control loop, which is on the left top. And here you can see responses for attitude stabilization, altitude stabilization, and position stabilization. And this is a short video demonstrating the autonomous waypoint flight. So this is the vehicle itself. It has GoPro camera attached. And this will be fully autonomous flight. So the vehicle is hovering fully autonomously, just maintaining the same position and altitude, and transmits all the information to the ground control station on the laptop, which is here. And this is the pre-programmed path, which it is going to fly now. So I just activated autonomous flight mode, and it's going to the first waypoint, which is here, then it goes to the second one, third, fourth, and after that, coming back home. So all telemetry information is available on the ground control station. You can also change the route even on the flight. The flight time for this vehicle is about 15 minutes, and the range and the altitude are mostly limited by the battery capacity. So after achieving the last waypoint, it comes back home automatically. Also here you can see the real-time video from the vehicle. And yes, has successfully completed the mission and hovering at the home position. So also you can take nice aerial images like this one, which was taken a couple of years ago during the open door days here at MIT. And also it's capable of doing very nice aerial panoramas. This altitude is about 100 meters, and I guess everybody knows the place. So this is Tsagi, the White House. You can see that the quality of the image is very stable. This is a 1080p high definition image. And the camera is attached to the brushless gimbal, meaning that it's moving the other direction of the vehicle. So you can see sometimes the arms of the vehicle, but the picture is very stable. So this is the central square of the town. This is the football field. It's between Dugina Street and Молодежная. So this outlet is a little bit bigger, about 150 meters. So this is also the square, the old part of the city. So yeah, very nice image, I guess. So how I let people know about me and about my project? I have the website, which is called the same as the project, sky-drones.com, where you can find the information, news, user guides, tutorials, demo videos, and contact us. Also, we do have a YouTube video channel where we loaded more than 100 videos with 85,000 views and have more than 150 subscribers. So, what about our customers and clients? So, the statistics allows to generate the number of views from different countries, and these numbers represent the number of visits from the beginning of this year. And we see that the main interest is coming from the United States, almost 20,000 views since the beginning of the year. The second place is Russia, then goes Germany, Great Britain, and Australia. And also, I already do have some customers which are located in these places. Some of them are companies, and some of them are just beta testers. So here you can see that it's again United States, Canada, Netherlands, Italy, Great Britain, Japan, Russia. And this information helped me to gain more knowledge about what customers need, about what the perfect flight control system should be like. So this is very valuable information. And this helped me to generate the state-of-the-art flight control system, which is called SmartUp 3. You can see the design here, and this is the picture of how it looks like. And again, here it is. So this meets all customers' requirements and all state-of-the-art requirements as well. And this is the bottom side. And here you can see the list of specifications. Here you can see. But I guess this is a little bit more deep in detail, so we just skip this slide. So our main competitors are two projects, which is PX4. This is the first project. The second one is AutoQuad. So the first one is designed by ETH University from Zurich, Switzerland, and produced in San Diego, California, United States. And the second one is again American project located in Seattle, Washington. But they do have some disadvantages, like lack of system integration. So special features cannot be added on your request. It's open source, but not very reliable. So only module architecture approach is available and possible, and they use a little bit obsolete electronic components. So in contrast, in my product, I can just offer all these disadvantages as advantage. And SmartUp 3 will be released for beta testers in December 2014. Last month, October, I spent in Japan working in collaboration with Chiba University in Tokyo, Chiba. So this is Autonomous Control Systems Laboratory headed by Professor Kenzo Nonami. And we did some system evaluation, some flight tests. We compared the performance of my system and their system, and we discussed some business opportunities on how we can collaborate to achieve the global market. So to summarize the information, I would like to say about what I have today and what I expect to have next. So now I have quite robust and working products. So the SmartUp 2 for just hobby and small research applications, and SmartUp 3 for professional applications. We have validated customer needs. We have some sales, more than 30 worldwide. The product is quite flexible and extendable. So soon we expect to continue the R&D to increase the production amounts and decrease production costs, and sell about 100 systems worldwide in 1 year. And after that, share the world market leadership. But if you're interested in that, I I can offer you to become a partner or contributor or something like that, and you can share the influence on tomorrow's UV world even today. And about 1 month and a half ago, I won CRDF Global USA Travel Grant. I was selected one out of more than 100 participants all over Russia. And this is going to be a business trip to promote my product and establish new contacts, as well as exchange experience with leading companies and evaluate the US market. Right now they are preparing the meetings with leading companies in California like Airware, 3D Robotics, and AeroVironment. So this is all actually. Thank you for listening to my presentation, and of course if you have any questions, let's discuss that and just ask me.